Okay, sure. Do you see the screen or not?
Yes, Doctor.
Yes.
Okay. Today I'm going to explain the mechanical properties of metals, part number 2. So what we are going to do today, I will explain the elastic and plastic strain. I think from the previous lecture, I will give you just a brief notes what we talked and what we talked about. And today I will continue with it. Elastic and plastic strain. What is called true stress strain diagram, strain hardening process or strain hardening region, and the ductility, toughness, resilience of the material. All of this property, in addition to the property we learned last week, is from one graph. It's called stress strain graph. Okay. Just reminding you what we already studied last week. We studied the stress strain diagram, and from the stress strain diagram from the beginning, we get the data, for example, from the machine. If you remember what you are talking in the lab, and then we take this Excel file, we transfer the elongations and loads to stresses and strain. Then we draw a graph is called the stress strain diagram. From the stress strain diagram, we get some point, and I told you how to get the yield point with 3 different methods, and in addition, how to find the youngest modulus of the material using 2 or 3 methods. If you remember, we get the ultimate tensile strength or tensile strength, the highest point in the graph from the graph, and we get the fracture strength. Okay. Today we'll continue with other property regarding to the stress strain diagram. Elastic and plastic strain. Let me go outside. I need to explain this to you because this is important to understand. Look at here, Ishbal. Look at this graph. If we have a graph like that, and from that graph, I will draw it here. Do you see the graph, Ishbal? Do you see the graph or not?
Yes, Doctor.
Yes, Doctor.
Please stop me if you don't understand any part. I will explain it to you. This is strain, and this is called stress. Okay? If I'm asking you, this point A is located here, and this is the yield. I told you, when you know the yield point, you know this is elastic, and this part is called plastic. Is that correct or not, Shabab?
Clear, Doctor.
Yes.
Okay, clear. If I have a point A, I will give you some number just as a demonstrative example to let you understand the case. If this yield point, I will give you some number. This is 100 megapascal. Okay. This is a megapascal. And point A is 90 megapascal, 90 megapascal. Okay.
It will be elastic.
Yeah. So if you apply stresses in point A, I'm in elastic zone, right? If you remove the load, what will be happen? If you remove the 90 here, what will be happen to the material? What will be happen? It will return it back to zero, صح يا شباب?
Yes, Doctor, because it's elastic.
Okay. Right. If I have point B, and point B, for example, this is 120. I apply stresses 120 megapascal. Then I remove the load at 120. What will be happen? Is the material or is what return it back to zero, or a little bit return it here? Right? So it will be returned here. There is a plastic deformation happen here. This is called epsilon plastic, right? Is that clear or not, Ashwab?
Clear, Doctor.
Okay. Look at point B. This is very important to understand this case. At point B, I can find the strain from the graph. Here it's called epsilon at point B. It consisted of 2 parts. Let us look at here as well. This part is epsilon plastic and epsilon elastic. So epsilon B from the graph is called total strain. عرفوا يا شباب؟ يعني I will give you some example. Let us say this strain, when you get it from the graph, is 0.2. Okay? And this strain, elastic الحته اللي هي الصغيره دي, let us say it 0.09. Okay? So the total strain from the graph, حد يطلعه لي كده يا شباب. What is the value at point B? What is the total strain? What is the strain? Go to the x-axis. What is the value? What is the value? شباب are you following?
When we add them, it's 0.29.
What's the value يا شباب؟ يا
Can
شباب
you repeat the point, doctor?
I'm asking you find the strain at point B. What I'm asking? Asking find the strain at point B from the graph.
0.2.
0.2.
Excellent. This is what I need from you. This is called total strain. This is called يا شباب ها بيسموه ايه ده يا شباب؟ Total strain. Okay يا شباب؟ This is called total strain. It has two values, epsilon elastic and epsilon plastic. So how to find the plastic strain from the graph? If you look at here, the plastic strain, I can find it is 0. كام يا شباب؟ ها from the graph كام؟ حد يقول لي؟ 0. كام؟
0.9.
9. This is a permanent strain happen. How to find the elastic strain? I can say elastic is equal to 0.2 minus 0.09. You can get it in that way. Okay, شباب? Okay, شباب or not? شباب 0.11. Okay or not?
If you can repeat it, please, doctor. I didn't get it.
Yeah, I can repeat it. I can repeat it. Look at here. This is yield, and this is point A. Point A located after the yield. This is mean plastic deformation. If you go down, this is called epsilon A, right? Right, شباب?
Right, doctor.
Yes, doctor. Yes.
Okay. If this returned back, if you remove the load at point A, is it returned back to 0? No, it will return it back here. صح يا شباب؟ So it has two value here. الفاليو الاولانيه دي, this is called plastic strain and this is called elastic strain. So we have two parts. Epsilon A always has elastic plus plastic. Is that clear يا شباب? Is that clear
Yes,
or
doctor.
not?
Yes, yes.
This is called elastic strain. And that one is called plastic strain. يبقى the value you get it from the x-axis from stress strain diagram is called total strain. Okay شباب؟ شباب okay or not? It has
Okay.
two values, epsilon elastic and epsilon plastic. Total strain is very simple to get it from the graph. Just draw a line, a vertical line, you will get the value of the total strain. But how to find the part of elastic and part of plastic? Let us go ahead. I will give it to you very brief, and if you understand it, you will solve whatever complicated problem. Okay, I can find the stresses at point A, right or not? Can you find the stress at point A? From the graph, go horizontal line, you will get sigma A. If I can get sigma A, we can find from the graph epsilon A, right? Elastic strain at point A is defined as sigma A divided by Young's modulus. Is that clear يا شباب? Is that clear or not? شباب, I need to hear from you. Nobody answering me.
Yes, doctor. It's clear.
Doctor, how do you get the Young's modulus?
Yo, I explained it last lecture. I already explained it and take more than 20 minutes to explain it. Have you reviewed the lecture, last lecture? Of course not. That is why you asked me how to find the Young's modulus. Okay? Have you reviewed the lecture last week? The guy who asked me right now. Can you answer me, please? Have you attended the lecture last week? Have you attended the lecture last week or not? Please answer me. Shabab, I don't need to lose this lecture. Okay, I don't need to waste the time for this lecture. You have to go through. The guy who asking me question, please answer me. Have you attended the lecture last week or not? I need answer, yes or no. That's what is happening. I need answer from the guy who asking me right now.